So your homework for today was to answer question 2, 4, 6 and 7 on page 177. So question 2. The graph of the function y equals x squared is shown. Use this graph to match the following functions with the functions shown on the graph. So y equals x squared is this one here identified in blue. That's the original function. We then have to figure out which one is y equals x squared minus 3 and y equals x squared minus 4. So comparing the original function y equals x squared to y equals x squared minus 3, the only change or transformation is this minus 3. So the rule from last week tells us if we have the original function and onto it we've just got a minus 3 or a plus something, we are simply moving up or down the y-axis. So we take a point in our original function, and because it's minus 3, we're going to jump down 3 places on the y-axis. 1, 2, 3, and here we go here. So this one here is the function y equals x squared minus 3. So that's I done. Then we look at part 2. So the red one here must be y equals x squared plus 4, but let's just check it out. So the only change between the original function of y equals x squared and y equals x squared plus 4 is this plus 4 added on. So that tells us we're going to move up the y-axis from the original function, the point in the original function, 4 places. So moving up 1, 2, 3, 4 takes me to here. So therefore I know this is y equals x squared minus 4. So the red one there is part 2. Moving on to question number 4. The graph of the function y equals x squared is shown, and again it's the blue one shown here. Use this graph to match the following functions with the ones shown on the graph. So straight away I can see there's brackets there, and those brackets, remember the rule told us we're shifting left or right on the x-axis. So how has the original function changed? We've got now brackets in it and something inside those brackets. So we have a plus 1 inside the bracket. We know plus 1 tells us we have to do the opposite, so we're going to go minus 1 on the x-axis. So taking our original function, we'll choose a point on it, and then all we're going to do is we're going to jump that point 1 place left on the x-axis, which then takes us to here, where our new point is, and then we recreate the graph. So this is y equals x plus 1 all squared, the red curve, which tells us then the one in black has to be part 2, but let's check it out and see. So the only way this has changed from the original function is we now have brackets, and inside the brackets minus 5. So minus 5 we know means shift the opposite direction. So that means go plus 5 on the x-axis. So here we go, we choose the original function, a point on the original function, and we jump 5 places to the positive on the x-axis. 1, 2, 3, 4, 5. Mark our point in and then complete our graph. So this is y equals x minus 5 all squared. Question 6. Graph the function f of x equals 2x squared plus 4 in the domain minus 4 to 3. So the first thing we have to do is we have to use our calculator and we have to work out our table of values before we can graph it. So you'll go to your calculator, you'll press mode setup and 3 for table. Then it'll come up fx equals. So then you'll input your function, which is 2x squared plus 4. So you'll type in 2. To get the x, it's alpha button and close bracket, squared plus 4. Press equals. Start is the smallest value in the domain, minus 4. Press equals. End is the largest value in the domain, which is 3, and press equals. And our step is 1, as our x values are going up in ones. Press equals and it'll give you the table of values, which is essentially our coordinates. So I'm just going to fill in the rest of these values here. So we have when f of x is 0, when x is 0, f of x is 4. When x is 1, f of x is 6. When x is 2, f of x is 12. I'm just going to put them up here to side 2. F of x is 12. And when x is 3, f of x is 22. And we've got these two out here as well. So we're just going to plot them. Minus 4, minus 1, minus 2, minus 3, over to minus 4. And up on the y-axis, I'm going to go up in 4. So 4, 8, 12, 16, 20, 24, 28, 32, 36. So minus 4 goes up to 36 is here. Minus 3 up to 22 here. Minus 2 up to 12. Minus 3 up to 22, so they're starting to vanish. Minus 2 up to 12 was here. Now I don't know why this is happening again this week. Then we have minus 1 up to 6. 0 up to 4. 1 up to 6. 2 up to 12. And 3 up to 22. And then lastly, we'll join them together. And that's roughly what my f of x looks like. Then I'm going to answer the question, so I'm going to change colour and answer the questions. So hence, so that means from this, sketch. So sketch means we don't use a table of values, it's estimates. The following functions, g of x equals f of x minus 3. So in other words, it's the original function, take away 3. So we know the rule is when it's just add or subtract hooked on to the end of the original function, it means we're moving up and down the y-axis. So here I'm going to move down the y-axis by 3. So if I'm at 4, so I'm taking this point, if I'm at 4 and I move down 3 spaces, it means I move down to 1. So I should end up here. So this is where my new point is going. And from there, I just draw something similar to the curve. And I'll call that g of x. And that's part I. Then I'm going to change colour again. And this time in part 2, it says h of x equals f of x, the original function, take away 6. So the original function take away 6 just means if I've add or subtract hooked on to the end of the original function, I'm moving up or down the y-axis. So I'm taking away 6. So again, I'm starting from the original function and I have to move down 6. So if I'm on the y-axis at 4 and I move down 6, that means I come down to negative 2. So I'm just going to mark in here negative 2. And that's where my dot will now be. And again, I just complete my function and label it h of x, and that's part 2. And now lastly, question 7. So we have the graph of the function f of x equals x minus 3 all squared is shown. Okay, so this is my original function. My original function has brackets in it already. So that's just the name of my original function. F of x equals x minus 3 all squared. And that's shown here in the diagram. Sketch the following functions. So what we have to do is we have to compare. So I'm going to choose different colours again. The first thing I'm going to do is I'm going to write down alongside it the original function, which was x minus 3 all squared. And I now have to look and see how is that original function changed in order to become g of x. So the first bit of it is exactly the same as the original function, x minus 3 all squared. And the only difference is I've added plus 6. So I've added on a plus 6. And we know when we just have something added on at the end or taken away at the end, it means we're moving up and down the y-axis. So I'm going to move up the y-axis 6. So 1, 2, 3, 4, 5, 6. So I've taken this point, I've moved it up 6, and again I'm just going to draw something similar to my curve. So it looks like this on the left and much higher than on the right. And that's now my function g of x, and I'll label that part I. Then I look at part 2, and part 2, changing colour, I'm going to do it in blue. The first thing I'll do is I'll write down the original function, which was f of x equals x minus 3 all squared. And I look and see, well, how has h of x changed from the f of x, the original function? So here is my original function. The only thing that's changed is I've the number 2 in front of it. So remember, when we have a number in front of the x squared, the original function squared, it means it's a narrow or a widen. And because the number is a whole number, it means it's a narrow. So again, we go back, so it's been narrowed to, so we go back to the original function and we're going to use this dot, and to show it's been narrowed, we just draw it, complete the function inside the original function. So something like this, and like that. So it's narrower, okay, narrower, it's closing in, and that is h of x, part 2. Then lastly, again, I'm going to change the colour, and lastly, we're going to look at I of x equals x minus 2 all squared. So I'm going to do it over here, part 3, I of x. So I of x equals x minus 2 all squared, and the original function f of x is x minus 3 all squared. So we need to figure out how did we get from the original function to the new function. So how do I get from minus 3 to minus 2? So if I have a number line, 0, minus 1, minus 2, minus 3. Okay, if originally, like the original function, I was standing at minus 3, but now I want to get to minus 2, how do I do it? I get it by plus 1. Okay, so plus 1 is what I did. That was the transformation that took place to get from I of x to, or from f of x to I of x, plus 1. So when it's happening inside the brackets, we know it's a shift left or right on the x-axis. And when it's a shift left or right on the x-axis, so shift left or right, and the rule is plus 1, we know we have to do the opposite of plus 1, so therefore we're going to go minus 1. We're going to go in a negative direction. So again, we take the point and we move it left 1. So hop it over to here, and now there's my transformed dot. So again, I finish it off by just drawing in my function. And this is called I of x, and that's part 3. So the left-hand side is the longer side, the right-hand side is the shorter side. So we have 3 sketches drawn there. We didn't use our table of values, we're simply just using the transformation rules that we learned last week.